Okay, so hello everyone. Here we will discuss perceptron algorithm. In the last class, you know that we have discussed about perceptron. In perceptron, one model was there. When inputs are coming, that perceptron can do the prediction. But here we are going to, if we want to create a perceptron model, so initially we don't know what is the exact weights. So using the perceptron algorithm, how can we find the optimal weights for a new perceptron model, so that when new inputs are coming, it can give us the perfect outputs. So okay, so here you see these are the steps of a perceptron algorithm. Okay, you see this is a perceptron model. Basically, you know that this is a simple artificial neuron, and here inputs are coming x1, x2. These are the inputs up to n inputs, and here these are the corresponding weights. So you see, so initially before you train a perceptron model, so what we need to know that, because initially we don't know what are the exact parameters like weights. Actually, our main target of perceptron algorithm to predict the perfect optimal weights and bias. Okay, so you see this is the bias and these are the weights. If you have doubt about bias and weights, you can see my previous videos related to perceptron. So here you see, so before initially we can give some random weights values to the weights, random values to the weights, and these values are maybe 0 or maybe some small values like 0 point something value we can initially given to the weights and the bias also. So initially we have to give some random weights, random values to the weights and biases, and also we have to define the learning rate. Learning rate, what is the learning rate? Actually, while the learning process happening, we have to update the weights, and this learning rate having an important roles to finding the weights. And if learning rate is higher or bigger values, larger values, so the weight update is going to be faster, the weight value is going to the faster. And if learning rate is slow, then weight update also slow. How can I explain? For example, we are going to a temple, and basically there is some steps are there. Okay, so every time a person can, while walking, so it can go step by step, so it can follow step by step. Otherwise it can at a time it can climb 2 steps at a time. You can climb 3 steps. If you are taller person, you can 3 steps, you can walk 3 steps, and you can go to the temple if the temple in available in a higher location. So this is the same manner. So learning rate if larger value, so at a time the way you are walking, your steps is higher. So to update, to reach from one place source to the destination. For example, our target to reach a destination, if you walk means with a large step, so number of step is less, so weight value also in the faster you can update the weights. So simple example of learning rate, you are walking from a source to destination, and while you walking, if your steps is larger, you can reach the destination very fast. And sometimes it also, the problem is if your steps is larger, you cannot reach the destination, you can go ahead of the destination. And if the steps are very small, the learning rate is very small, so it will take a large time, the weight update is very slow, it will take long time to reach the destination. So that's why the learning rate has having an important role. So we have to find a right learning rate so that our weight update will happen properly. Okay, so learning rate is there, and it is given in the question in the exam. And threshold, you know that here is the step function. Okay, so to predict the output, you need that threshold. If the weighted sum value greater than the threshold, the output is going to be 1. If the weighted sum value less than the threshold, output is going to be 0. Okay, so here you see, so these are things we need: weights, bias, and learning rate, threshold. Step number 1, we have to find, initialize these things, random values for weights and bias, and in the question learning rate and threshold is given. Okay, so in the step 2, so for each training example, in the question you may have a data set is there, and in the data set each row is one example sample. So for each sample we have to update the weights. Okay, so for each sample, for example, if I create a data set, for example, and a data set, So here let me create the data set. You know that AND logic, all of you know, I think all of you know that AND logic very well. So you know that AND gate circuit, okay. So this is for AND gate data set, okay. So AND gate is for combination of 0 0. You know that AND gate is output is equal to 0, and if your combination is 0 1, output is going to be 0 1 0, combination output is going to be 0, and also for when both are 1, your output is going to be 1. So this is the thing, okay. So this is the AND gate data set. So here you see x1 and x2. So here this part is known as input x, and y the corresponding output is holding the class level of this input. So for each training example for each row, so we have to update the weight. How? There is a formula. So you have to calculate the weighted sum. Okay, so for this data set, let's create the perceptron. So this perceptron is like that. You see the perceptron. If I draw the perceptron, it is going to be like that. So here you see, let the diagram is, this is the perceptron. Okay, I'm creating here. If my perceptron is, so here how many inputs in this data set? Two inputs are there. So one is x1 and another input is x2. So two features are there in the data set. So first we have to find the weighted sum. So you know z value is the weighted sum. Weighted sum means what is the z value? You know this is the weights, and these are the two weights, two input, and here in the question there is no bias factor is not available. No need to use that. So first we have to find the weighted sum. So z value is equal to, what is the value? w1 x1 plus w2 x2. Okay, this is your weighted sum value. You have to first calculate the weighted sum. After that, this weighted sum value we have to provide to our activation function. Okay, what is the activation function? We have to provide this thing, and activation function is going to give you the predicted output. Let predicted output is y cap. Okay, so you know that this is a step function, and how it is going to be 1 if z value greater than equal to threshold. Okay, 0 otherwise. Okay, so we do that. So here it is written. First thing is you have to calculate the weighted sum. Weighted sum we have to calculate. Then you have to predict the output using the activation function. That is step function we are using here, the step function. Okay. So let's start with the example we will do. Let me explain. After you finding the output for each sample, you have to find the error. What is error? For the data set, this is the real output, real class level, and here y cap what? Y cap is the predicted class level. So we have to find the difference. So if both are same, if predicted output and real output both are same, then we can say there is no error. The model predicts perfectly. But if predicted output different, real output different, there is error. So we have to find that error. Error is equal to y minus y cap. Y is the real output and y cap is the predicted output. Okay, so so that error is going to help us to update the weights. So how? The weight update formula is old weights plus eta, the learning rate, into error into your inputs. Okay, we will see this how to do. And what is b plus learning rate into e. Here we are not written xi because you know that your for b, for bias, x equal to always 1. So that's why here x is not, part is missing. So we have to update the weights. So for this is a loop. This is going to do for all the training samples. So now this algorithm will process according to the question. So here the AND gate question is given. Okay, AND gate data set is given. Initially weights also given, w1 equal 0.9 and my w2 also 0.9. Initially it is given, and also my learning rate eta also given. What is eta? Eta is my eta equal 0.5 also given, and also I have also all these 5 things are already given. Learning rate threshold also given. So threshold value is also given, that is 0.5. All the things are given. Now question is how can we use Perceptron algorithm to update the things? Okay, let's use that. So there are two ways to do that. For each step you can do, otherwise in a line we can do. Okay, step by step is better. So now I am going to apply this Perceptron algorithm to get the updated value of W1 and W2. So how? So now let's take as for step number 1. So first what we are going to do? So now let's take the first sample. Okay, the first line. So first line, what is my x1? So my for first line, my x1 is equal to 0 and my x2 is equal to 0. And what is my real output? My real output y is 0. Okay. Now you apply this thing in the model. Okay. 0 now here my x1 equal to 0 and x2 equal to 0. Now I have to find the z value. So now do the z value. Now z value is equal to w1. W1 is my 0. W1 into x1 plus w2 into x2. Okay. So now calculate this thing. If I calculate here, my z is going to be w1 is my 0.9 and x1 is equal to 0 plus w2 equal to 0.9 into my x2 also 0. So my z equal to 0. Now I am getting z equal to 0. So now this z is here. My z value is equal to 0. 0 is coming. So now 0 will pass to this activation function. Activation function use the formula. If z value greater than threshold, so what is threshold? Threshold is 0.5. 0.5. Threshold value is 0.5. So you see. So here you see now the z value. Now how to get the y value? Y is equal to, we have to apply the threshold. Now z value 0. Since z value 0, now according to the activation function, phi of z is going to give me 0. Why? Because according to this formula, z value less than threshold, my threshold equal to 0.5, my 0 is less than 0.5, so output equal to 0. You see, so what happening here in this table, my predicted output, okay, the real output 0, predicted output 0. Then what is the error? So error is equal to y minus y cap, 0 minus 0, 0. So here no error. If there is no error, then no need to update the weights. Weights are perfect. So how to why updates are not happening? Because if I use this formula here, so I can write W1 is equal to W1 plus eta into error into x1. Okay. Then what is my W2? My W2 is equal to W1, so W2 plus eta into E into x2. So put the values. So W1 initially 0.9. So your W1 how much? 0.9 plus eta equal to 0.5. Error is 0. X is 0. So this total thing is 0. So 0.9 plus 0, which is equal to 0.9. So that's why no need to update the weight. If error is equal to 0, the same value. You see here, weight it was before 0.9, now also 0.9. And the same manner, if you follow this thing also, you find 0.9 into plus 0.5, error equal to 0, x2 equal to 0. So this is also 0.9. So what you got that? You got that in both cases. You got that if error equal to 0, no need to update the weights. So it is going to be step. So now let's go to the step 2. Step 2 means we are going to take the second example. Okay. Here we are going to the second example. So in the second same manner we are going to proceed. Okay. So space is not available. Let me remove some parts. Okay. So up to this I can remove. Okay. So okay, so now you step 2, we follow the same thing, step 2. In the step 2, what is x value? X1 equal to 0, x1 equal to 0 and my x2 is equal to 1. Okay, so what is the real output? Real output equal to 0. So now we have to find our z value. So every time remember that for input, now input equal to 0, x1 equal to 0 and my x2 equal to 1. So do the summation value z, multiply this. So now you do the same formula multiplication. now z is equal to my words are formula w1 x1 plus w2 x2. You do this. Okay, so here w1 equals 0.9, x1, what is x1? X1 here you see 0 plus w2 equals 0.9 into what is x2? X2 equal to 1. Okay, so what is my value now? This is 0, 0.9. So final answer is 0.9. Okay, I hope you got it. So z equals 0.9 for second case, this case. So you got that z value 0.9. Okay, so here you got this is 0.9. So this z is equal to 0.9. So 0.9. So what is the threshold? The 0.9 is the output. Now here if I put 0.9, my threshold is 0.5. So z value is greater than 0.5. Okay. So according to the concept. So here what is the my output y cap, y prediction? Y prediction is equal to that is your phi of z, which is going to, what is the this is going to give me 1. Why? Because z value, since z value greater than equal to 0. Greater than equal to my what threshold. What is the threshold value? 0.5. So since my z value 0.9 greater than equal to 0.5, my output here equal to 1. So you see, what is the real output? 0. What is the predicted output? 1. So you see here error is coming. Here the real output 0, predicted output 1. So find the error. Now error is equal to error E is equal to, so what is the error here? Error E is equal to y, what is y? 0, y minus y cap, which is equal to 0 minus 1, which is minus 1. So here error is coming. Error coming means you have to update the weights. So now we'll update the weight. So my W1 is equal to, my W1 is going to be equal to W1 plus eta into error into x1. Okay, so now proceed this. So W1, what is our W1? W1 is equal to your 0.9. What is eta? 0.5. What is error? Minus 1. What is x1? X1, what is your x1? 0, I think. X1 is 0. If x1, so if you multiply, this term is going to be 0. So this 0.9 plus 0, which is equal to 0.9. So W1 remains same. Now let's go to update W2. Okay. Now let's go to update W2. Okay, so here you see what is W2. W2 is equal to W1 plus W2 plus eta into error into x2. Okay, so W2 how much? 0.9. What is eta? Eta is equal to, what is your eta? Eta equal to 0.5. What is error? Minus 1. What is x2? X2 equal to 1. So here you see 0.9. If you do the calculation, it is minus 0.5. So it is going to give me 0.4. So here error or update happens. So here our this weights is going to use in the next step. So here for this step, weight equal 0.9, W1, W2 equal to 0.4. Okay. So now proceed to the next step. So means another example. So here. Now go to this example. So let me remove this part. Here everything. Now you see here. So step 3. Okay. In step 3, what is going to happen? This is now the input. X1 equal to, your x1 is equal to 1, x2 is equal to 0, your y real value equal to 0. Okay. Okay, before we proceed, we updated the weights. So what is my weight now? W1 equal to 0.9 from the previous step. And what is my W2? This is updated 0.4. This thing we are going to use. Okay. So now this one x1 now here 1, x2 here 0. Okay. So for this example, my W1 0.9, my W2 updated here. This is my 0.4 here. Okay. Now apply x1, this thing you apply, find the weighted sum. Now my weighted sum z is equal to W1 x1 plus W2 x2. W1 x1, W2 x2. So which is equal to, what is W1? Let me proceed here. W1 equal to 0.9 into x1 1 plus w2 how much 0.4 my x2 0. So if I do the calculation, I will find here 0.9, this part is 0, it is going to remain same. Okay, so 0.9, so my z is 0.9. Now again this z value 0.9 go into here. So what is y cap? Y cap is equal to, again we are going to use this thing now. Your y cap is equal to your threshold you are going to use. Since your 0, this is 0.9 which is greater than your threshold case. Okay, so it is going to give me 1. Why? Because z value is greater than threshold 0.5. Since my z value greater than 0.5, so it is going to predict 1. So here predicted value what is 1. What is the real output? 0. And what is the predicted output? 1. So here we have to do the weight updation. Okay, so do the weight updation. My W1 is equal to W1 plus eta into error into x1. Okay, now continue here. W1 how much here? 0.9 plus what is eta? Eta 0.5. What is error? Error minus 1. I got error minus 1. So okay, I remove. Okay, here you write error is equal to y minus y cap. You know that is 0 minus 1. Okay, so you, and what is x1? Your x1 equal to how much? 1 here. Okay, 0.9 minus 0.5. So which is going to give me 0.4. So this is 0.4. So here, that means here we have updated the weights. W1 now 0.4. Now proceed for 0.1 W2. What is W2? Again same thing, W2 plus eta into error into x2 0. You know that what is your W2? 0.4 plus what is eta? Eta is 0.5 into error. What is error? Minus 1 into what is x2? X2 equal to 0. So that means this total line now 0. This part is 0. So 0.4 plus 0. Okay, so step 3 completed. So W1 weight we got 0.4, W2 0.4. Now move to the step number 4. So in step number 4, input x1 equal to 1, x2 equal to 1, and output is also 1. And here also we are going to use the weights from the previous step. W1 weight is now 0.4, W2 is equal to 0.4. Okay, so now we have to calculate. So here the inputs like that 1 and 1. And weighted, so here we are going to use the weighted sum 0.4, 0.4 like that. So here weights are like that 0.4, 0.4. Now we have to calculate the weighted sum. So weighted sum formula, let's you know that W1 x1. So let's the weighted sum z is equal to W1 x1 plus W2 x2. Okay, so my W1 is equal to 0.4, my x1 is 1 plus my W2 is 0.4, my x2 is 1. So total 0.4, 0.4 is equal to mine is equal to 0.8. So I got 0.8 as my means value of z. So this z value now go to the threshold part too. Okay, so now how to find the y value? Y predicted y value is equal to, you know that threshold, you have to provide this to the step function. And here the z value 0.1. You know that according to the step function, if the and also threshold value 0.8, it is going to provide me 1 because z value is greater than threshold 0.5. Z is 0.8 which is greater than 0.5. So my threshold value is 1. So my y cap value is equal to 1, my predicted value. So now you see here the real value 1 and predicted value 1. So now we have to find the error. So what is the error? Error is equal to, you know that y minus y cap. Y the real output and y cap real output is 1 and predicted output also 1. Both are same, so there is no, you can say 1 minus 1, 1 minus 1 both are same, the 0. No errors, I already told you. If there is no error, then no need to do the update, no need to update these weights. So it is going to stop here. So finally what we got after one epoch? What is one epoch? Epoch means all. So we have to update the weights for all the training examples. So for all the training examples we have updated. So the whole training example is one epoch. So one epoch completed, we have updated all the weights. So finally we got that my W1 equal to 0.4 and my W2 equal to 0.4. So this is my final weights. So let's check that in the next round, in the next iteration, in the next epoch, if I try to put this value, can my model doing perfect prediction? See here, my W1 0.4, W2 0.4, and let's try from the beginning with the inputs. Let's see how it is predicting. Is it predicting perfectly or error is coming? So if I provide here x1 equal to 0, x2 equal to 0, now let to predict the y cap. So you see your W1 0.4 into x1 0 plus W2 0.4 into x2 0. That is my z value now 0. If you do the calculation, you will find that z value equal to 0. Okay. So if you pass it to the activation function, you know that this value is less than your threshold 0.5. So your output is 0. So predicted output 0. That means my real output and predicted output is perfect. If you continue like that, in the second case, if you find z value, it is going to give you 0.4. If you do the calculation, you will find z value is 0.4, which is less than your threshold. So the predicted output now in this time, the predicted output is going to be 0, not 1. So it means what happening, the weights what we got, it perfectly doing the prediction. You can try. If you apply these inputs for this weights, you will find that the real output and predicted output is going to be same. So that means this model converges and the weights updation perfect. This is ready to do the prediction. Okay, I hope you understand. Thank you. If any question, ask me in the comment box. Thank you. See you in the next video.